friends, and welcome back to my channel. In today's tutorial, you are going to learn how to differentiate radical expressions like this using the first principle. But you know, as usual, I always give you a tip on how to do it using the formula method. Okay, so make sure you watch through the end as I show you these two methods and then you choose the best, and let's do it together. So what we have here is y as the root of x plus 5. I will start with the formula method, okay? Remember, for your formula method, if you have y to be equal to x to the power of n, then your dy dx, okay, let's make it clearer. We have formula method. For the formula method, if y is equal to x to the power of n, then my dy dx is equal to, use the power to multiply, you have nx, then take away 1 from the power. This is what you have when you are using the formula method. Remember, your formula method is also your power rule. Noted. So, can we do this? You may ask, but this one is radical. It's not power. Don't worry, okay? We can express a radical sign as an index. So in that case, remember, for your indices, this is the same as x to the power of half. I hope you know that. So for this question now, it can say to be y is equal to x plus 5 all to the power of 1 over 2. So this means this. So we can now apply the rule, okay? Now to apply this rule, what do? We are going to do a little adjustment to this rule. What we do here is, you will notice that what you have here is x, but what you have inside this bracket is x plus 5. So I'm going to do a little adjustment, okay? Just follow through. So what you're going to have is dy dx is equal to, as usual, use the power to multiply. So we're going to have half, okay? Then I will now have my x like you have it here. Let's take this to be the whole of that, my x. So we have x plus 5, okay? This, I'm taking it to be my x. So we have x plus 5. Then what happens to the power? You have half already, then subtract 1 from half. I hope that is cleared. Use the power to multiply. The whole of this is taken to be our x. So we left it like that. Then also subtract 1 from the power. But since this is x plus 5, what we need to do is to differentiate this inside also. And to differentiate x plus 5, what do? If you differentiate x is 1. So differentiate it is power of 1. What you need to do is, if you differentiate it, it will give you 1x, then subtract 1, it will be 1 minus 1. Whenever you differentiate a constant, it is 0. We have said it in our previous tutorials, okay? So this is x to the power of 1 minus 1 is 0 plus this 0. And x to the power of 0 is 1. I hope it's clear. So what it means is that if I differentiate x plus 5, I'm going to have 1 plus 0, which will give us 1. So to differentiate this, I will get 1. I hope that is clear. So did you see the adjustment we said we are going to make? Okay, we made the adjustment because what we have in the bracket is not just only x, like here. It is now x plus 5. So you differentiate it also. That is the adjustment. Okay, so we are now going to have half into x plus 5. Whenever you multiply anything by 1, it gives you back that answer. Then when you have half minus 1, will give us negative half. Okay, so remember, this means this is the same thing as when you have x plus 5 to the power of negative 1. This negative, simply, if I have x to the power of negative half, it means this will turn to 1 over. So we have x to the power of half, which is the same as 1 over. This will become the root of x. So this is what you have when you have this. So for this, what do you have? It will be 1 over 2 multiply. This will now turn to be 1 over. Then we have x plus 5 to the power of half. I hope it's clear. So it will give us 1 times 1 is 1 over. This is 2. This will now form the root. So we have root x plus 5. So this is what we are going to have if we differentiate this using the formula method. I hope that is clear. Okay, but this is not what we have come for. What we want to do, let's bring it down here. What we want to do today is to look at how to use the first principle. So ensure to pay attention. And if you are new to this channel, don't forget to subscribe to us for more of these are coming. And let's know your thoughts in the comment section. Give us a thumbs up if this impresses you. Now, let's use the first principle. So what we are going to do, our guide. In the first principle, our dy dx is equal to the lim of f of x plus the change minus f of x all over change as this change tends to 0. This is your key each time you are to use the first principle, if you are using this. Okay, so what do you do now? Let's bring this down. We have y is equal to root of x plus 5. So what do you do? Think. What do we do? What we do first is to add we are going to add the little changes to each of these. So to add that, we are going to have for y, we add change in y. I hope you are following. Is equal to root of, for x, we are going to have change in s added to it plus 5. I hope it's clear. For your y, add your change to your y. For your x, for the variables, add their corresponding changes. So this will be change in x plus this 5. We are not adding anything to 5 because 5 is a constant. So at this point, we are going to make change in y the subject. Okay, so we have change in y is equal to root of x plus change in x plus 5. Then remember, this is positive here. If we move to the right side, it will be negative y. So what do we do again? Think. We are going to replace this y with the given value of y. Okay? That is the second step. Subtract this function given. So we are going to have change in y is equal to root of x plus change in x plus 5 minus our y from the question is this, which is root of x plus 5. What do you think we should do next? What we need to do next is to simplify this. But you know that this will be very complicated for us to simplify. But remember in your solved or radicals, that the only way you can simplify a radical solved in this manner is by rationalizing it. What do you mean by rationalization? It simply means remove these radical signs. So to remove the radical signs is to rationalize. And when you have something like this, you first of all conjugate before rationalizing. Let's look at this. If you have 1 over 3 plus root x, if you want to simplify this, you need to rationalize by conjugating the denominator. So the conjugate will now be 3 minus root x. So change the sign. Use what you have up to also put it down. This is what you do. For doing this, it means you're rationalizing. Now, for this, remember, we rationalize the denominator, but here we are only going to rationalize this. Okay? So what is it? What are we going to do now? What we need to do here is, we are going to multiply this by the conjugate. So what will be the conjugate? The conjugate will be the root of x plus change in x plus 5. Change this sign from negative to positive, so it will be plus root of x plus 5. Use it also to multiply the denominator. Remember, this is over 1. So we're going to have root of x plus change in x plus 5 plus root of x plus 5. This is what we do, and it means you have rationalized this numerator. I hope it's clear. But to do this, it's very complex for us. We can simplify by saying, let's x plus change in x plus 5, everything inside this root, let it be equal to a. Okay? Then let also x plus 5, this, be equal to b. So in that case, you can say that our change in y will now be equal to root of the whole of this. You have changed it to the a for easy simplification. Okay? Then minus the whole of this, we have changed it to be b. So we have this over 1 is multiplied by root of, this has taken a plus root of b over root of a plus root of b. I hope it's now simple. But remember that in your difference of two squares, that if I have a squared minus b squared, it means a plus b and a minus b. I hope that is clear. So it means if you look at this, you notice this is root a, this is root a, this is root b, this is root b. The difference is in the signs. So it means we can use difference of two sorts to give us, this will give us, for the numerator, it will give us root a all squared, okay, minus root b all squared. This is the same as what we have here. All over, 1 multiply this will give us root a plus root b. So at this point, we can simplify. This can cancel this can cancel. So we are still having change in y is equal to, this is a minus our b, all over, this is root a plus root b. I hope that is clear. So what do you think we should do now? At this point in time, what we need to do here is to simply put in the values of what we have. Okay, let's put in the values to conclude with what we have. So we're going to have, this is a, our a is x plus change in x plus 5 minus our b. So we're going to put our b in brackets, x plus 5. Please put it in brackets so that this negative sign will affect all that you have. Is an expression. This is over root x plus change in x plus 5 plus our b is x plus 5. So what do you do next? This will give us what? We can move it up here to conclude. So this will now give us, so we are going to have change in y is equal to, this is x plus change in x plus 5. Remember, this negative sign will affect this. So we're going to have negative x minus 5 all over. This will give us root x plus change in x plus 5 plus root x plus 5. Okay? So what happens? This will take care of this. 5 will cancel negative 5. So we have change in y is change in x all over root of x plus change in x plus 5 plus root of x plus 5. So what do you do next? Remember, the next thing is to introduce your change by dividing. Okay, so we're going to divide this by change in x. To divide this means to multiply by 1 over. You know, when you have this, it means change in y multiply 1 over change in x. It means we multiply this to the both sides. So we're going to multiply this also by 1 over change in x. So in that case, this can cancel this. So we have change in y over change in x is equal to, this is 1 over root of x plus change in x plus 5 plus root of x plus 5. So finally, what do you have? At this point, you introduce your limits as this change tends to 0. So in that case, we can say as change in x tends to 0, we can now have dy dx. Each time you introduce your limits, change this from change to dy dx. So we're going to have 1 over, okay, we can clean this. We still note our answer down. Root of x plus, replace this with 0. So we have 0 plus 5 all over, this is plus root of x plus 5. And that will give us 1 over, this will give us x plus 0 is 0 plus 5 is root of x plus 5 over, this is plus root of x plus 5. Okay, and that will give us 1 over, you see this is 2, the coefficients are 1. So add their coefficients together, it will be 2 root of x plus 5, which is the same as what we have here. So this is what we get for our dy dx. So for differentiating this, we get the same answer by the first principle and use of formula method. I hope you learned a lot in this tutorial. Please don't forget to give us a thumbs up, share this video with your friends and colleagues. Remember to subscribe to this channel for more of this are coming, and also leave your thoughts with us in the comment section. I'll meet you next. Till then, stay cool and bye-bye.